Welcome, future business leaders. In today's world, making the right call can literally make or break a company. So, how can you be sure your biggest decisions are built on solid ground? Well, we're about to dive into an incredibly powerful machine learning tool that helps you do just that, the random forest algorithm.
So here's our game plan. First, we'll talk about the risk of relying on just one expert. Then, we'll see how to build a much smarter forest. We're going to peek inside that black box, explore some real-world business plays, and wrap up with a blueprint for your own capstone project. But before we jump in, just think about this for a second. What is the actual bottom line cost of a bad prediction? We're talking customer churn, market shifts, supply chain failures. Getting it wrong is expensive, and that is the exact challenge we're tackling today.
All right, so that leads us right into our first big idea, the problem with relying on just one expert. You know, in machine learning, that expert might be a single decision tree model. And putting all your faith in it, that can be a huge and often totally hidden business liability. Check this out. A single decision tree is kind of like relying on one advisor. Sure, it's simple, but it's also risky. It's really prone to something called overfitting, which basically means it gets way too obsessed with the tiny details of your past data and completely misses the big picture. But a random forest? That's like having a diverse panel of experts. By pulling all their insights together, you get a much more balanced, stable, and accurate prediction because you're smoothing out the weird biases of any one individual. Okay, so how do we actually build this amazing panel of experts? Well, that brings us to section 2. We're going to build a smarter forest by tapping into an idea you already know, the wisdom of the crowd. And this quote, it just nails the core principle. A diverse group of independent thinkers will almost always outperform a lone genius. Random Forest uses this exact same logic, creating hundreds of unique decision tree experts and making sure they don't all think the same way. So how does it guarantee this diversity? With two really clever tricks. First is something called bootstrap sampling. Imagine you've got data on 100 customers. To build one tree, you randomly pick 100 customers, but with replacement. That means some customers might get picked twice and some not at all. You do this over and over for each tree, so each one gets a slightly different perspective on your customer base. Then there's random feature selection. At every decision point, instead of letting a tree look at everything, age, location, purchase history, it's only allowed to consider a random handful of those factors. This forces each tree to find different patterns, which makes the final collective decision so much stronger. Right, so you've got this whole forest of decision trees. How in the world do they come together to make a single final call? Let's take a quick peek inside the black box. You'll be surprised how simple it is. So for what we call a classification problem, like will this customer leave us, yes or no, every single one of the hundreds of trees we built gets to cast a vote. It's either churn or not churn. And just like that, the majority vote wins. It's literally a democratic consensus. And this process is what makes the final prediction so much more stable and reliable than any one tree's opinion. Now, if you're trying to predict a number, like sales figures, it's the same idea. It just takes the average of all the individual predictions. But look, prediction is only half the story. The real strategic magic comes from understanding the why. This is where a concept called feature importance comes in. For instance, a model predicting why employees leave might tell you that overtime, monthly income, and job satisfaction are the biggest factors. See, this isn't just a prediction, it's a strategic roadmap for your HR department. So, in simple terms, feature importance turns this complex model into your strategic guide. It literally points out which factors are moving the needle on your outcomes so you can stop guessing and start focusing your resources on what truly matters. But how do we know we can even trust this thing? Well, it has this brilliant built-in quality check. Because of that random sampling we talked about, each tree is only trained on about 2/3 of the data. That leftover 1/3, that's called the out-of-bag data, and it's used to automatically test that tree's accuracy. It's like having a built-in, continuous audit for your model, which gives you huge confidence that it's going to work in the real world. Okay, let's get practical. It's time to open up the strategic playbook. This isn't just a tool for data scientists, not at all. It has some seriously powerful applications across every single function of a modern business. In marketing, random forest can be an absolute game changer. A simpler model might just find a straight line, you know? The more a customer spends, the less likely they are to churn. But random forest can find the tricky, non-linear patterns. It might discover that customers who buy a very specific combination of products, even if they don't spend a lot, are actually your most loyal advocates.
That insight lets you create way more effective, personalized campaigns. Now think about the high-stakes world of finance. Here, Random Forest is a beast at things like credit scoring and fraud detection. A traditional model can get totally overwhelmed by the sheer number of variables, but a random forest can sift through thousands of data points to find those super subtle patterns that scream risk or fraud, giving you a critical edge. And for HR and operations, it's all about making that crucial shift from being reactive to being proactive. In HR, you can predict who might be a flight risk and step in before they even update their resume. In operations, you can forecast demand with incredible accuracy to optimize your entire supply chain. The advantage is crystal clear. It gives you the hard evidence you need to manage your talent and resources proactively. So, let's bring this home. For your big capstone projects, how can you actually use this? This last section is your personal blueprint for turning a powerful model into a powerful business recommendation that's going to seriously impress your professors and your future boss. Here it is, a 4-step framework for your capstone. Step 1, justify your model choice. Don't just use it, explain why Random Forest is the right tool for this specific, complex business problem. Step 2, interpret that feature importance. This is key. Go beyond just the prediction and tell the story of what's driving the results. Step 3, evaluate its performance. Use metrics like the OOB score to prove your model is reliable. And finally, and this is the most important part, translate all of it into clear, actionable, data-driven recommendations a manager can actually use. So if you remember just one thing from all of this, let it be this. Random Forest is not just some technical algorithm for making predictions. Think of it as a strategic framework for understanding complexity, for finding out what really matters, and ultimately, for building rock-solid confidence in your most important business decisions. And I'll leave you with a final thought to carry with you. What high-stakes decision in your industry is still relying on the equivalent of a single decision tree? One expert's opinion, one gut feeling, one old report. And just imagine how much value is waiting to be unlocked by building a smarter forest.